Hi, welcome to the Calculus 2 lecture series. And this is unit number 2, Techniques of Integration. This is our second video for the lecture number 11, Approximate the Integration. So this is the lecture we talk about sometimes when integration becomes hard to find. And in order to find the definite integration, we can definitely use the approximation method. So similar like the Riemann-Sum concept, right? So for the first video, we talk about the 5 different estimation approaches we can use. Okay, so this video we're going to focus on, how to estimate the error by using each approximation. What is the maximum error, we can, by using different type of the approximation. All right, so now let's go to our lecture notes to continue here. All right, so here, if you remember, when we did our first video, we talk about 5 different methods here, right? We have a left-hand approach, right-hand approach, midpoint, and the trapezoid, and the Simpson rules, right? And so in here, we're going to just try to take a look what is the maximum errors, when we try to use those approximations. And so how much errors are we going to, so what is the maximum error? So of course, those errors depends on how many subintervals you do, right? Okay, so now let me write it down for you. So for the midpoint, okay. So if we use the midpoint, so this will be let's do a tables here. This is our rule, and this is the conditions for all the x in AB, the intervals here. Then here, this is the max error of estimations here. So it will be depend on how many intervals, subintervals you divide. We know, the more subintervals you use, the better the accuracies, right? Okay, so if you use the midpoints methods, try to estimate, then in here, if we can find some value like f double prime x here, if less than or equal to k, so if we can find these conditions here, then the maximum errors we're going to get will just be this k value, then it's minus times b minus a to the cube. Okay, so I'm sorry, not the square, so it's a cube here. So it's b minus a to the cube and 24. And now this is n to the what? N to the squares here. Okay, then if I use trapezoid, rules, then what is the conditions here? So same things here. If the f double prime x in all the x in AB, if you can find some of the k for all the value in AB, then the maximum errors we will have, it will be k to the b minus a to the cube, and then the 12 and the n squares here. Okay, so if I'm using the Simpson rule, okay, so if I use the Simpson rules, then if I can find here, this one here is I take the fourth derivative, and if I can find is less than equal to some case here, then in here this will be the kb minus a to the 5th power, and this is 180, and n to the what? N to the fourth, right? So like, how do we derive this? This we're not going to prove it, and the people did research for that. So the key things here, the simple thing is the fourth derivative, and then here is like the n to the fourth and the different constants here. All right. So by just compare like midpoint trapezoid, right? So you can see, the midpoint will have the accuracy, the maximum error for the midpoint is less than the maximum error at the trapezoids here. Okay, so now let's take a look. Some practice. Let's take a look some of the problems here. So first things here, remember this is max errors here, right? So the true error probably, will be less than that. Okay, so I want to find the maximum error estimate -1 to 3x to cube when n is equal to 8 by using the trapezoid, right? So by the trapezoid, we from the previous page, I know the maximum error is what? The maximum error is the k, and the b minus a to the what? To the cube, right? And then I have 12 and n to the square. So basically, I just need to find what is the k. So the maximum errors here, so this is k, b minus a, so it's 3 minus 1, so it's 4, right? So it's 4 to the cube, and then 12 times n to the what? N is a, n to the square, right? So the 4 to the cube is 64, 8 squared is 64, okay? So I know the max error. So the max error for this problem will be what? K over 12. Okay, so let's try to see if we can find the k or not. Okay, so f of x here, this is a pretty easy one. So this is x cubed. Then the f prime x is what? Is 3x what? 3x squared. Then f double prime x is equal to what? Is equal to the 6x, right? So we know the 6x here. So we know the x is from -1 to where? -1 to 3, right? So the 6x here, the absolute value of the 6x, so this is the absolute value of the f double prime x is going to less than equal to what? Equal to 18, right? So this 18, this is what? This is my k value, right? So now my max error will just be 18 over 12, so it's 1.5. So that means if you divide this integration into a subintervals, and then the max error you use trapezoid to estimate is 1.5. So if you don't, so this one is easy. We can physically integrate this one. So this is x cubed dx. So this one you integrate, this will be x fourths, right? Now you have 3 -1. And so if you integrate this one here, so this one you can get a true number is 20. Then if you use the trapezoid method we learned before, so the trapezoid with n equal to 8, if you use what the method we did from the from the previous, just do a table and then try to find it. And then you can find the trapezoids here. Okay, so then we use the T8. So the trapezoid will give you a nice, the value is 20.5. So the errors here, right? So take a look at the true values here is 20, and the trapezoid is 20.5. So what is here? So the errors here is what? Is 0.5, and this error is within my maximum errors here, right? So here, this is what we call this max error is 1.5. So we know this is correct. Okay, so Now let's take a look here. I want to find the maximum errors for this integration by using the Simpsons here. Okay, so the Simpsons here, we know the max error based on the formula I wrote there will be K, the B minus A to the fifth power, and what, 180 to the nth fourth, right? Okay, so the K, the B minus A is 2 to the fifth power, then 180 times n is 4, so it's 4 to the fourth here. So if you cancel that and simplify, you will find this is equal to the K over 144. Well, not 144, 1440 here. So 1440 here. All right. So this is the maximum error. So we're going to have for the, so this is the max error. All right. So I need to know is right now to find this case, right? So the same things we can say f of x is equal to the sine 2x. So f prime x is equal to what? 2 cosine 2x. Then f double prime x is equal to what? Negative 4 cosine 2x, right? Okay, now f triple x, it will going to be 8 cosine 8 so this will be the, so it's the first one, okay. So the second one, oh, I'm here, this is sine, right? So this is, so cosine, take the derivative will be negative sine, so sine 2x. Then the sine, take the derivative will be, so this will be 8 cosine, right? So have a negative 8 cosine 2x. Then I have a fourth derivative, so it will be cosine, it will be 16 sine 2x here. All right. Okay. So the now my x is from 1 to 3 here. Okay. So now I know the sine 2x is always what is less than equal to 1, right? Because sine function is always less than equal to 1. So the fourth derivative of x is here going to be what? Will be 16 sine 2x. So what is going to less than equal to? Less than equal to 16, right? So I know now the 16, this is what? This is my K value. Now I can plug into the, I get the max error. It will just be 16,1440. And I will get something very close to 0.0111. That means that this is the max errors, right? Now, let's this one is also easy to integrate. So let's take a look at the, if I really integrate this one is 13 sine 2x dx, then you will get this is 2 negative cosine 2x, right? So the 3 to 1, and you will get a value very close to negative 0.688, okay? Then you use the method like we did before and to create a table and do the Simpson. So in here, I'm not going to redo that. So I just said if we do the Simpsons here, then the Simpsons estimation will be close to negative 0.6925, okay? So it's fixed 6925. So if you find the, this is a true value, this is the estimate value. So if you find the differences will be the 0.6925 minus 0.6882. So it will be somewhere. So the differences here. So the errors here will be kind of close to 0.004 0.043, something like that, right? So 0.043 is what is within the what we expect. So it's within the maximum error. So as you can see, if you use the Simpson for the the least estimations, then you can get even only with like 4 sub-intervals, the maximum error you will get is within the 2 decimal point. So that's really pretty good estimation methods here. All right, so this video is short and it's just a quick video to show you how to find the maximum error. That means the depends on the samples, the sub-intervals you choose, then the error of the estimate will be bounded by this maximum error. So if the real error probably will be a lot smaller than this maximum error, and so this is the table and this is the formulas. Those are the formulas, for each test, the midpoint, trapezoid, and the Simpsons here. Okay, that's it. And now we finished this lecture. Then our next lectures will be the last lecture for this unit. We're going to talk about how about, when you do the integrations, your upper lower bound is infinity. So how do we do those things? All right, that's it. Have a good day and talk to you later. Okay, bye-bye.